grid, and I want to create 30-degree theta. Just like that. Okay? When I draw a 30-degree theta, that allows me now to understand what my sides are going to be. Because in a 30, 60, 90 triangle, the generic form was always x, x root 3, and 2x. Did it work?
Yeah.
All right.
Thank you.
No problem. Now, that means instead of using the values of x, x root 3, and 2x, I'm going to use numbers. So what is the value am I going to put across from the, or excuse me, opposite the 30?
60.
What is the value of the side? Excuse me.
X.
I'm going to use 1 instead of x.
Okay.
All right? I'm going to use 1 here. That means root 3 goes here, and what is my radius? 2. So that means this spot has an ordered pair of what? We have an ordered pair of x is root 3, y is 1. Okay? That's the ordered pair at that spot. Now, here's what happens. If we redraw this triangle, there we go. If I redraw this triangle, over here is my 30-degree theta. Notice how the 30-degree theta is bounced up above the 180 degree. It's mirrored going this way. Is this still opposite the 30? It's still 1, correct? Opposite the 60. Now this direction, it's a negative square root of 3, which means this ordered pair now is at negative root 3 and 1. No, because when you use the Pythagorean theorem, is your hypotenuse ever going to be negative? Is therefore, will your radius of the circle ever be negative? No. Do this again. If I clone this same spot and I flip it, so I know you guys can do this all day long. To here, am I now still just bounced off 180 degrees, 30 degrees down below that? So I have bounced 30 degrees off again. This value here is negative root 3. What is this value here? Negative 1. So that means this ordered pair is at negative root 3 and negative 1. Okay, let me go again. If I flip it around again to go back to the fourth quadrant, I still have a 30-degree angle off of 360. Everybody agree with that? So it's still bounced off of the off of 360, and notice my x value is still the same value. Oops, excuse me, positive square root of 3. But now what's my y value? Negative 1. The reason that this works is because of this reference angle here. Each one of those ordered pairs has the reference angle that's the same, which means that this rectangle is formed, which allows us to mirror our ordered pairs by just reflection. Reflection and flipping things around the axis, which you guys might have done in geometry at some point. What reference angles do is it allows us to be able to find our special right triangles in the first quadrant and mirror their sines and cosines throughout the rest by doing nothing more than what we just did by flipping our triangle into each individual quadrant with the exact same theta off of the x-axis. Does that make a little bit of sense? Again, our reference angle is going to go through the following. And what we need to look at here is nothing more than, none of that words, it's annoying, we don't need that much, is this. when I'm looking at a reference angle for an angle that is in the second quadrant, a reference angle for an angle that's within the second quadrant, give me an angle degree that's in the second quadrant.
27.
Second quadrant.
130.
130. If I say that theta is 130 degrees, it's in the second quadrant. Everybody agree? Okay. In order to figure out its reference angle, all I do is take 180 and I subtract 130. My reference angle is 50 degrees. Would be the reference angle. Now, what that means is, if I was in the first quadrant with the 50-degree angle, and I knew its cosine or its sine, in the second quadrant, well, the sine value would be the same because the y values are the same. The cosine values would be the different sign. When I say sine, I mean SIGN in this case. It becomes negative. The whole idea of being able to use a reference angle is to be able to identify your special right triangles that are going to be in the first quadrant to mirror everything else out. This is where everything is built off of. Everything is going to be built off this reference angle. So what we're working on today is just finding reference angles. All right? If I'm in the second quadrant and I'm dealing with something in terms of radians, that means I'm between pi over 2 and pi. Everybody agree on that?
Yeah.
So if I say it's 7 pi over 8 is my theta. If I say 7 pi over 8 is my theta, well, that angle, again, will lie within the second quadrant. How many pi's do I have to get? Is that off of the x-axis? 1/8. So I would say that its reference angle would be pi over 8. The reference angle there is how far is it off of the x-axis. These reference angles are always going to be positive value. Okay? Works the same if we were going into the third quadrant. If I'm going into a third quadrant, I need a third quadrant degree. 210. Everybody agree? So if I'm at 210, I'm coming around past 180. How many more degrees is that than 180? 30. So how far is it off of 180 degrees? 30. There's its reference angle. If you're in the quadrant 3, if your angle is in quadrant 3, all you have to do, take your theta, subtract 180. That'll give you your reference angle. Works the same if it's in terms of radians. If you're in the third quadrant with radians, 7 pi over 6. That's more than 1 pi by how much? 1/6. So what's the reference angle? Pi over 6. Very good. Again, in this case here, it goes around 1 and there's a 1/6 more. So that meant that its reference angle is pi over 6. Yeah?
What do you mean take theta and subtract 180? So you take 30 and subtract 180 if you're using 30
This is my original theta amount.
Oh.
My original
Oh,
angle.
okay.
Excuse me, I might not have said that.
Never mind.
This is the reference angle.
Oh.
The book calls it theta prime. It's the reference angle. All right? Yeah.
What about other ones you do? 7 pi over 8. How do you get pi over 8?
For a second quadrant,
Yeah.
what's pi minus 7 pi over 8? How much pi is left to get to a full pi? 1/8. What I did there is there's one of two things you can do. To get to within the radians, if you're taking pi and you're going to subtract 7 pi over 8, the easiest thing to do is create this to have the same denominator. Remember we did a little bit of that before? We were adding and subtracting them? 8 pi over 8 minus 7 pi over 8 is? Pi over 8. Does that make more sense? On that one, all I had to do was take 7 pi over 6 and subtract out pi, or in other words, I subtracted out 6 pi over 6 by just using common denominators to get real fast fractions. So if you're in third quadrant in degrees, you subtract 180. If you're in third quadrant in terms of radians, you subtract pi. Yeah.
So you're always trying to get something, you don't have to be like in the first.
Your first quadrant are the reference angles of themselves. So if you have a first quadrant angle of 22 degrees, what's the reference angle? 22 degrees. How far is it off of 0? It's 22. If I'm in the fourth quadrant, though, am I doing what? Well, let's see. Give me a fourth quadrant angle.
300.
300. Okay.
300.
If I'm at 300, if theta's at 300 degrees, it's over here. Now, how far is that from 360? So what did you do? You subtracted it from 360 or subtract 360 from that?
Yes.
No.
It's 360 minus theta. Okay. It is. So it's 60 degrees here for the reference. Now, if I'm talking about that in terms of radians, what's 360 in radians? 2 pi. So you take 2 pi and you subtract theta. What we're doing here, guys, is we're finding out how far they're bouncing off of the x or the y axis. It's really all it is. All right? I'll show you an example. 2 pi over 3. If I'm going to look at 2 pi over 3, I have to first of all figure out which quadrant it's going to land. Is 2/3 bigger than a half or smaller than a half? It's bigger than a half.
Second quadrant.
Say, can I have 2/3 of your dollar and you can have half of mine?
Second quadrant.
All right.
First. Same
All right.
thing. English was.
Anyway, we all agree that 2/3 is bigger than a half, but smaller than a whole, right? So that means it's a quadrant 2. So there's 2 pi over 3. What's the reference angle? The reference angle here is pi over 3. You've got pi over 3 left to get to the 180, or think of it in terms of pi. Okay. What changes if you're going negative?
That makes sense. Can you just look at your unit circles?
Not all of these are going to wind up on the unit circle. I'm using ones that are because I want to try and start going to that. Tonight, what you'll have, I think, is a mixture of ones that are and aren't. And I'll explain to you what you're going to need to be able to do here pretty soon.
All right.
If I'm at negative 120 degrees, what quadrant do you wind up in?
Second. Oh.
Third quadrant. Negative 90 to negative 120. Okay? There's your negative 120 degrees. We went the other direction. How far off of this is it from 180? 60. So the reference angle is still 60 degrees. It is still a positive value. You can think of it just by looking at it upside down. With 120, you still got to get to the 180. No, your reference angles are always going to be positive. Okay? It's just telling you direction. You just have to start playing around with where it's going to wind up. Okay? Same thing goes for if it's in negative radians. If it's a negative radian, negative 11 pi over 4. If I'm at negative 11 pi over 4, I'm going the other direction, but I also have to figure out which quadrant I'm going to wind up in. So if you remember from yesterday when we did some of these drawings, or 2 days ago, how many times does 4 go into 11? It's 2 times. And how many were left over? 2 and 3 pi over 4. So this means I'm going to go the other direction. Here's -1, -2, -1/2, -3/4. What quadrant did I wind up in? Third quadrant. What is the reference angle? Very good, pi over 4. Okay? Again, what we're looking at here is to figure out which quadrant we would map out where our angle lands, and then how far is it off of the x-axis is basically all this is. All right? Now, the main super duper reason as to why this is going to work is because of the following. If I take, which one was it? If I take the cosine of 315 degrees and I want to know what its value is, I need to first figure out what quadrant it lies in, because you're not going to have a calculator. Well, it's a fourth quadrant. How far off of the x-axis is it?
75, 45.
45. So its reference angle is 45 degrees for theta. Okay? Now, when I take care of this, that means this endpoint here has some specific ordered pair. That ordered pair is the same ordered pair up here with theta at 45 degrees. What changes is that down here, which one of them is negative? The y value, the sign is negative. So if I know what the cosine of 45 degrees is, what's the cosine of 45? Root 2 over 2. X root 2, special right triangle.
I know, but it's one away.
What's that?
It's just example of triangle.
It's just an example. This is just, instead of saying it's x root 2, I says 1 root 2. All right, it's the same ratio. Now, what happens here is that this is the cosine value, correct? Because it's the x coordinate. Remember, cosine was x over r, which means there's your cosine. And again, like I was showing you guys a little while ago, it's going to mirror itself here, it's going to mirror itself here, and back here, because each one of these has that reference angle of 45 degrees. What changes are the signs. And by signs here, I mean S-I-G-N. Positive and negative. I know. Okay? That's where this is where all of this is heading. This is why we have to understand how we find our reference angle. Where are we bouncing back and forth from? So the other part of being able to do all of this is also being able to do this. So there's two parts to tonight's homework. The first part of tonight is I want you guys to make this following table.
Go calculator.
I want you to start forgetting it in your locker.
For real? I got that covered.
What I want you guys to do is make a trig table for the special right triangles. I'd like you guys to take a couple of minutes and fill that in by drawing out your special right triangle. Fill it in and rationalize it. And I want you to be able to try and do that without using your calculator. And after you do those, there are only, I think, 8 other ones that are working with reference angles. The reference angle problems I'm going to give you guys aren't necessarily off a special right triangle. They might be, 170. It could be 27. It could be 3 pi over 8. You know, it could be any of those. It doesn't necessarily have to wind up being a 30, 60, 90 or a 45, 45, 90 triangle to have that specific of a reference angle. But it's still the same basic principle. So, first thing to do tonight, create that table. The second part is, what problem?
That's our homework?
On 788, 37 to 44. So I want you to make this chart, and I want you to do those 8 reference angle problems. When you do the reference angle, try to remember to draw it first, give you an idea, especially for any of the weird ones that help you figure out where the loop goes. Because then tomorrow we're just going to start working without calculators.
So
And-
no calculators, don't bring it, don't.
Now you can bring it. All I'm saying is that the skills that we're going to work with tomorrow and leading into 13.4 is basically going to become non-calculator.
Okay.
There will be calculator parts of the problems, but for the most part, when it's going to say evaluate the trig function like cosine of 315, you're going to have to be able to crank that out by hand. All right,
Do you want us to give the answers in decimals or fractions?
like this for these things.
Yeah.
This should all be simplified radical form. There should never be a decimal value for any of this. Okay? Like I said, if it's 30 degrees, what's the sine of 30? Well, that's 1/2.
Right.
The cosine of 30 would be √3/2. And just leave it like that. All right? When you go to do your inverse, just rationalize things out.
Didn't
Okay.
we make this
We did a little bit of this before, but not a lot of it. So go ahead and work on that. Like I said, we'll build off of that tomorrow then. Okay?
Wait, Mr. Murphy, does the table have to be in our